You might already know this, but it's possible to find the slope of a curve at a point using your calculator. So today we're going to learn how to do that. And that's a big deal because it's a lot quicker than doing it by hand, even the shortcuts. But before we get to exactly how that works, we need a little bit of background. So the title today is NDER, and that stands for Numerical Derivative. And that's what the function on the calculator is called, the numerical derivative. So let's have a function f of x equals x to the fourth. And the first thing we're going to do with that function is find the average rate of change on the interval 2.999, comma 3.001. So this is what we've been doing. So you just take f of 3.001 minus f of 2.999 and then divide by 3.001 minus 2.999. So nothing new yet. This is just the average rate of change. Kind of annoying to be using these long decimals, but still the same concept as what we've been doing. F of b minus f of a all over b minus a, the average rate of change. Okay, so I got to plug 3.001 into the function x to the fourth. See what decimal that is. So 3.001 to the fourth power. It's like 81.108, et cetera, et cetera. I don't want to round yet, so I'm going to go ahead and subtract 2.999 to the fourth. And that's like 0.21600000024. And then you divide by 3.001 minus 2.999. And it comes out to 108.0000012. So this is the average rate of change of this function from 2.999 to 3.001. Okay, since both of these numbers are 0.001 away from 3, we say that h is 0.001. So h represents the distance you are away from the center. So the middle of 2.999 and 3.001 is 3, and both of these are 0.001 away from 3. So we just say that that's the h. And this average rate of change right here is called the numerical derivative. So it's just another name for the average rate of change. So this is the numerical derivative. And it's there's different numerical derivatives. This is the numerical derivative with the h equaling 0.001. But you could do a numerical derivative with the h equaling 0.0001. And then you would just figure out the average rate of change from 2.99999 to 3.0001. So there's different numerical derivatives with different h's. Okay, so that's called the numerical derivative. So now I'm going to show you how to use the calculator to find the derivative at 3. calculator to find f prime at 3. Okay, so if you have your calculator with you, you should do this. It's Math 8. And most people probably have a newer type calculator where you get a D over D. Is there anybody here who doesn't have that D over D thing? Okay, cool. So I'll show you guys. I'll talk about what to do in a second. So tune out, because yours is different. All right? So those of you who have D over dx, well, you don't have an x down there yet, so you have to put an x in there. So press the x button, so it says D over dx. And then in the box after the D over dx goes the function. So what's the function that we're taking the derivative of? X to the 4th, so you just do x to the 4th power in that box. And then there's a line and an x equals. The x equals needs to be what number you're trying to find the derivative at. So we're trying to find the derivative at 3, so you're going to put a 3 after the x equals. So it should look like this after you're done typing. Has everybody been able to get that? Okay, so then you press enter, and you get 108.0000012. Did everybody get that? Okay, does that look familiar? It does look familiar, right? So when the calculator calculates a derivative, it's doing this. So it's not exactly accurate. It's pretty darn close to accurate, but it's not exactly accurate. Okay, so Brandon and Michael, you have NDER and then a parenthesis, right? Okay, so you put the function in first, so x to the 4th. And then you put a comma. The comma is right under sign. And then you put an x. So here's what you've entered so far. The x to the 4th, the function. And then the x that you just entered is what you're taking the derivative with respect to. So remember on Friday we did DDR. So this is ddx, so that's why you had to put a comma x. And then another comma, and then the 3 to tell it what to take the derivative at. And then you close the parentheses and press enter. And hopefully you get this. Did that work out? You get the 108? Okay, cool. All right. So not much different except you put commas in between your entries. Okay, so now we're going to calculate f prime at 3. I should have said find f prime at 3 exactly, but you know I already wrote f prime at 3, so I decided to talk like you a little bit. So the way to find f prime of 3 exactly is to actually calculate it by hand. So you take the derivative, that's 4x cubed. And then you plug 3 in. So then 3 cubed is 27. And then 4 times 27. 4 times 20 is 80. 4 times 7 is 28. And 80 plus 28 is 108. So the exact right answer to the derivative is 108. Okay, so here's what's going on. We've got our x to the 4th function. And we want the slope at 3, right? So the 108 is the slope, the exact slope of that tangent line. But what the calculator does instead is it picks a point right next to it, right? 0.001 away. H equals 0.001. And then another point right next to it. And it calculates the slope between those two. And those 2 points are so close to the actual 3 that the slope of that secant line is almost identical to the slope of the tangent line. If you picked points way out here for your average rate of change, then the average rate of change there would be radically different than the slope of the tangent line. But if you pick points extremely close, like the calculator does, then it's very, very close to the slope of the tangent line. Okay, so that's called the numerical derivative because it's so close that it's good enough. And on the AP test, you're supposed to round to 3 decimal places. So if you rounded this to 3 decimal places, then it would be exactly right compared to that. So the calculator picks numbers that are so close that it's good enough for our rounding purposes. Okay, so you can consider this answer, 108.00012, as the right answer. But then in the back of your head, you need to know that it's not exactly right. But whenever you calculate a derivative on the calculator active portion of the test, you're allowed to do Math 8. You don't have to do it by hand. You don't have to do this ever on a calculator portion of a test. You can, you're allowed to, but you don't have to. You can always use the calculator. So as the year goes on, I'll say, well, why didn't you just Math 8 it? And you'll say, oh yeah, I forgot. You're so used to practicing this type of stuff that you'll forget that that function exists. So on the calculator active portion of the test, don't forget to use that because it can save tons of time. Especially if it's like a product rule or a quotient rule that was annoying to do this way. That would be a lot quicker. Okay. So now we're going to change functions and have f of x equal the absolute value of x. And we're going to find the average rate of change. Around x equals 0 with h equals 0.001. Find the average rate of change around x equals 0 with the h equals 0.001. Okay, so that means that I'm interested in 0. I'm interested in what the slope is at 0. But I'm going to go 0.001 to the left of 0, and I'm going to go 0.001 to the right of 0. So that means I'm finding the average rate of change on this interval. Just like on the last one, I went 0.001 to the left of 3, and that took me down to 2.999. This is 0.001 to the left of 0, and it takes me down to negative 0.001. So this is just a rephrasing of that same question as we had before, just using the h terminology. Okay, so we're going to take f of 0.001 minus f of negative 0.001 all over 0.001 minus negative 0.001. Same question, just find an average rate of change between 2 points. All right, so if f of x equals the absolute value of x, and I plug 0.001 into that, I just have to take the absolute value of 0.001. That's 0.001. And then if I take the absolute value of negative 0.001, that's 0.001. And then 0.001 minus negative is the same as plus. So it'll be 0.002. And 0.001 minus 0.001 is 0. And 0 divided by 0.002 is 0. So the average rate of change between these 2 points is 0. Okay, so now for part B, we're going to find f prime at 0 on the calculator. So you just press Math 8. So practice again there so you don't forget about it. Got to put the x in, d dx. The absolute value is under Math, and then go over to Num, and then press Enter, and that'll get the absolute value symbols on your screen. Or if you're Brandon or Michael, it'll say ABS on your screen. Then you put your x in your absolute value, right? And then at x equals 0 is where we're trying to figure out, right? Stop me if I'm losing you because you can't see this. So is everybody okay with typing this stuff in? So you should get 0. Does that surprise you that we got 0? No, because I told you that this is what the calculator does, right? And so, of course, what we did on A should be the same as what the calculator got on B, because the calculator uses part A to calculate part B. Okay, so now we're going to find f prime at 0 using a graph. So we're going to graph the function y equals the absolute value of x. What does y equals absolute value of x look like? It's a v, good. So this. So what's the slope at 0? What's that called there? Called a corner point, right? So what happens to the slope at a corner point? Doesn't exist. So f prime at 0 does not exist. We can see that there's a corner point there, so that means the derivative doesn't exist. This is the right answer. So that's bad news, because on this problem, the calculator gets the complete wrong answer. Calculator is saying 0. That's not correct. The actual answer is does not exist. Okay, so that's a problem. That means that Math 8 doesn't always work. Over here, it was off by 0.000012, and we were okay with that. That was close enough. But over here, it's off. It's very off. 0 is very different than does not exist. So you have to keep in mind that when you use Math 8, sometimes it's totally wrong. You also have to keep in mind sometimes it's slightly wrong. Well, it's actually always slightly wrong. Keep that in mind. But also keep in mind that sometimes it's totally wrong. So what's going on here is, if you find the slope of 2 points around 0, you do get a flat line, right? So the average rate of change between those 2 points is 0, and that's what the calculator is doing. So that's why the calculator gets the wrong answer on this problem. What it's been instructed to do, and I think they have, with more powerful computers, figured out how to tell a calculator where a corner point is, but that's a complicated concept to tell a calculator where a corner point is. So that your calculator doesn't know that, and so you do know that, so you have to watch out for that. Yeah. When we calculated the average rate of change. This is not the derivative. This is the slope of this line, right? So it's not really the derivative. So when the calculator calculates derivative, it's not really doing the derivative. And in some ways then, I like Brandon and Michael's screens better. Because NDER is the numerical derivative. So your calculator in some sense is being more honest with you. It's calculating the numerical derivative. Whereas their calculator indicates that the calculator is calculating this, but it's not calculating this. This notation means the derivative. So in some sense, you have a fancy calculator that isn't being completely honest with the notation. It's actually doing this, not the numerical derivative, not the actual derivative. Okay. All right, so for part D, for that example, we're going to find f prime at 0 using the definition. So the definition of derivative is the old cumbersome way. So when you do limit as x approaches a or limit as h approaches 0, that's the original way to calculate a derivative. That's the way that works for everything. And so now we're going to go back and practice that some more. We've done it on the calculator, but it gave us the wrong answer. Then we did it on the graph. We know it doesn't exist. So now we're going to calculate it this way. Okay, so since we're finding the derivative at 0, that means we should put a 0 in these spots. Okay, so f of 0 means take the absolute value of 0, so that's 0. And then f of 0 plus h means take the absolute value of 0 plus h. Okay, so 0 plus h is just h. So that's the absolute value of h over h. Okay, so now absolute value behaves differently depending on whether you have a positive or a negative number, right? So I'm going to split this up into the two different limits. I'm going to come towards 0 from the left and towards 0 from the right. Take the limit towards 0 from the left, and then separately take the limit towards 0 from the right. Okay, so over here, when we approach 0 from the right, we're plugging in stuff like 0.001. And that's a positive number. So what does absolute value do to a positive number? Doesn't do anything, right? So I could just get rid of the absolute value signs. So since h is a positive number, absolute value can just go away, because absolute value doesn't do anything to a positive number. Then h divided by h is 1, and the limit of 1 is 1. So that answer is 1. Okay, over here though, we're plugging in things like negative 0.001. So we can't just get rid of the absolute value signs, because absolute value of a negative number is going to spit back a positive number. So what's another way to take a negative number and make it positive? Multiply it by negative 1, right? So instead of absolute value here, I'm going to take negative 1 times the number. So for example, let's say h was negative 3. If I take the absolute value of negative 3, that gives me 3. Or if I take negative 1 times negative 3, that also gives me 3. So absolute value behaves exactly the same way as multiplying by negative 1, as long as you have a negative number. So that's why I was able to replace this with that, because they behave the same way. Okay, and then I got an h on the bottom, and I'm taking a limit. And then the h divided by h is 1, and negative 1 times 1 is negative 1. And the limit of negative 1 is negative 1. Okay, so I took the limit from the right side, and I got 1. And I took the limit from the left side, and I got negative 1. So what does that mean about this overall limit? Doesn't exist, right? And this limit was the derivative at 0. That's what it is. So that means the derivative at 0 doesn't exist. We already knew that, right? We already knew from part C that since there was a corner point there, that the derivative doesn't exist. So we're not surprised that we got does not exist as our answer. Okay, so again, the main point is, though, that if you use the calculator to calculate the derivative at 0 for this function, you get the completely wrong answer. So you can't just use Math 8 without thinking. But don't let that discourage you too much, because most of the time it works pretty well. So I'm telling you the dark side of it, but it's good news that we have Math 8. Because calculating a derivative at a point really quickly using Math 8 is really, really nice. It's going to save you a lot of time on the half of the test that you have your calculator. Of course, the other half you don't. But on that half, it's going to save you a lot of time, if you remember to use it. And I keep saying this over and over again because we practice during class not using the calculator. And so people in the past years have tended to forget about Math 8 and the fact that it exists. So don't forget to use it on the calculator portion of the test. Okay. Let's see. We're going to have f of x equals 5 times x cubed. And for part A, we're going to find f prime of x using the product rule. Okay, so if I'm looking at this from the perspective of the product rule, my first function is 5, and my second function is x cubed. So the product rule says take the derivative of the first thing So that's the derivative of 5. What is the derivative of 5? 0. Okay, so the derivative of the first thing times the regular second thing, and then plus derivative of the second thing, which is 3x squared, times the regular first thing. Everybody following the product rule okay there? Okay, so then when you get your final answer, the 0 times x cubed is nothing, because 0 times anything is 0. And then 3x squared times 5 is 15x squared. Okay, so if you use the product rule, you get 15x squared. And it's fine to use the product rule. But we learned something that was easier, but it was a while ago. How do you take the derivative of a constant times a function? Yeah. Yeah, we learned a rule that said you could just bring the 5 out front, right? It was a while ago. It was the beginning of last week. So that's 5 times the derivative of x cubed. And then, of course, the derivative of x cubed is 3x squared. And then if you take 5 times that 3x squared, you're going to get 15x squared. So, of course, you get the same answer. They're both right. It's just that this one is quicker. But since we just learned this on Friday, I think today people might have tended to do it this way and forget about this way. And I've noticed over the years that people get them mixed up. So I wanted to connect the old way with the new way so that you'd see, it's not a big deal. You can do it either way. But don't forget about the constant rule. What people do is they see this and then they say, oh, that's 0 times x cubed, so the final answer is 0. That's the wrong way. They see the 5 and they say, oh, the derivative of 5 is 0. And so this final answer is going to be 0 because 0 times anything is 0. And that's mixing up these two rules. All right. We got one last problem here. This would be example 4. And the function that we're going to work with is p of t equals 100 over 1 plus e to the 3 minus t. And t is going to be days. So it's time measured in days. And then P is going to be a population. It's the number of people that have the flu. Okay, so if you plug in 5 into this function, when you get a number out, it tells you how many people have the flu on the 5th day. And then if you plug a 7 into the function, it'll tell you how many people have the flu on the 7th day. So it just outputs the population that has the flu. Okay, so for part A, I'm going to ask how fast is the flu spreading at day 2. So how am I going to figure out how fast the flu is spreading at day 2? So should I plug a 2 into here? You can tell by my tone of voice that the answer is no, right? So, but why shouldn't I plug a 2 into here? If I plug in the 2 into here, what does it tell me? Yeah. Yeah, how many people have the flu at day 2? And that's not what the question is asking. The question is asking how fast is it spreading? Okay, so how do I figure out how fast it's spreading? It's the derivative, right? Yeah, because if you have a function that inputs days and people, that's what P of t does, right? Then slope will be the people per day that are getting it. So that's how fast it's spreading. Okay, so this question is asking us to find P prime at 2, right? So then what's the quickest way to figure out P prime at 2? Math 8. Plug in that function and 2, right? Now when you plug in this function, you have to be a little bit careful. Make sure you divide by all of this, right? Don't just divide by 1. And if the t bothers you, there is a way to change it to a t, but you're allowed to just use x. The variable doesn't matter. Remember, the E button is second divide. So if you type that in correctly, you should get 19.661. Why did I round to 3 decimal places? Because that's what we do every time in AP Calc. That's what they want on the test, so we're just going to do that all year. Okay, so it's 19.661, and then what would the label be? People per day, right? Because the graph is people in days, so the slope is people per day. So that means at day 2, I'm saying at because it's instantaneous. At day 2, the rate at which people are gaining the flu, the number of people that are getting the flu, is 19.661 people per day. That doesn't mean that 19 people are going to get it in the next day. This is an instantaneous rate. So maybe 1 hour later, the rate has changed. But right at midnight on day 2, the rate is 19.661 people per day. That's why it makes sense to leave it as a decimal. Because an instantaneous, some of you are thinking, you can't, 19.661 people can't get the flu. Well, it's an instantaneous rate. So we're just saying that's how quickly right there. Okay, so now we're going to, for part B, graph P of t. Got too much in my hands here. So graph P of t, and I'm going to tell you the window to use. The window is 0, 10, and 0, 150. So now we're going to our y equals button. And we're plugging in P of t. And go back to your window and change to 0, 10, and 0, 150. And when you do that, you should get something that looks like that. So where does it look like this graph has the biggest slope? Somewhere in here, right? And I'm guessing maybe 3 or so. But I'm guessing, because I'm just looking at it, and I can't tell for sure, right? Okay, now for part C, we're going to graph P prime at T. And we're going to graph it without ever finding it, because I don't want to take the derivative of this. It's a pain. And for that matter, I haven't even taught you how to do it yet. Okay, so go back to your y equals, clear out the old function, and type in math 8. So then put your x in, and put your function in, just like you've been doing. So then you get to the x equals, right? Here's the thing that's a bit tricky, so listen. I'm sorry to rush you. It's because it's getting to the end of the period. So here's the thing you got to know. You don't want to know the derivative at x equals 2. You don't want to know the derivative at x equals 3. You don't want to know the derivative at x equals 4. You want a graph of the derivative at any point, right? So you want to know the derivative at x equals all x's. So you put an x after that x equals. So you're indicating to the calculator that you want it to figure out the derivative at every x, 2, 3, 5, 7, 9, plot those points and connect them to get a picture of the derivative. Okay, so I don't know if I have to adjust the window, but looks like it's going to be okay. So here's a picture of P prime. And where's the biggest derivative? Looks like at about 3, right? Thanks for listening.